So I think we can start. My name is Noam. Actually, it's my third year here in Scala UA. I think the first year I was talking more about like test clean code and stuff like that. The second year I was talking about my open source library. But this year I chose to speak about one of the, like a project, a plain project that we used, and we used several features in Scala to make things easier. And we'll go through the process of doing that throughout this lecture. Don't worry, we're not going to translate everything here or anything here. I'm starting to learn Russian, but no, it's not the lecture, the content of the lecture. One of the things, anybody's familiar with Wix a little bit? Cool. So one of the things that Wix is actually built from, when you go to a Wix page, it actually contains several products, several services, and all of those services, like for example in this web page, you can see that you have one part which is the editor and the static pages and everything. Another part is the store, and it's a different service altogether. And another thing is booking, and a user can mix and match every one of them, and everything is basically for the end user, it looks seamless. But Wix products are localized, so every product has its own language, and all of the languages are supported, of course, but the user data itself is not. So if a user enters a product into our store solution or our bookings solution, his data is not translated. And one of the features that was requested of us is to allow our users to translate their own page to different languages, like every other page that you see on the internet. So the feature that what was asked of me when I was trying to architect and start coding this is that we wanted a main place for user to see, like a CMS, we call it now TMS, but a single place where someone can translate that our user can translate his data. And we also wanted to allow the verticals to easily integrate with that. One of the things that I learned in my career is that if you build something that is very complex to integrate with, well, you'll see teams just dragging legs and saying, okay, we'll do it next month because we're very busy. So if you want to integrate with all of the products, then you have to have like very, very easy integration. And it takes a while. One of the approach, we could have gone many different ways, because we didn't want every vertical to implement his own solution, but we also wanted to have a simple. We also had like cases where all the data was sitting in a specific service. So at the day we started investing in this solution, we had already a lot of services in production. So we had to add on this. So one of the things that we decided is that to keep the main language and the data as it is, but if a user is requesting in runtime a different language, a user of user, or like someone who watches the web page, if he asks for another language, then before we return the result to the service, then we override it with the overridden language. So, for example, if a user would ask for the site version in French, and the main language is in English, then if we'll retrieve from the database the English language, and then we'll replace everything that was translated into French and return it back to the API. Make sense? Okay. Or not. So the tale that I'm going to talk to you about throughout the service, or throughout this lecture, is how we use several Scala features. Some of them are a little bit more advanced, some of them are getting to be obvious, but still how we use Scala to make integration easier and how we were able to pull through this. So at first, how did we start? So we had a client that will retrieve the translation. So you can see that the user can have any type of case class here. And there are several parameters that we need. So for example, if what is the site, which tenant does this call is talking about, which service is talking with us, of course, which language he wants to translate, and at the end, a function that translates. So we have a certain case class, a map of strings, and we want to return the same entity. So this is the code that actually, when you call this, the result would be a future of the entity that we need to be translated. So what can be, it looks a lot of parameters, and we want to make it shorter. So the first thing, let's start with the obvious thing. There are constants, like for example, service ID, it's not going to change. So we can remove it. So in the factory that creates the client, we just take the constants and move it out of the way. Very simple. Second of all, site ID and languages are environmental and call context parameters. I think everyone has like his own solution. I saw several of them. We were switching from one solution to another. Right now, the solution that we use is we have an implicit call scope, and we can retrieve it from there. So it's available to our client, and the client retrieves the language and everything. This is an entire topic for a lecture all to itself, because like I said, we switched from using thread local, and there is this whole thing with when you do using asynchronous and parallel and everything, it really changes everything. But still, if it's an infra that we have, and we move it there. So we're getting better. We have only 3 parameters. Let's do a small refactor. Because we had 2 functions, let's just extract them into a trait and move them out of the way as well. So now we have just 2 parameters. How do we reduce that? We have this translator that's accepted into the function, and we might even want to remove that. Why not? If you have less parameters, it's actually easier, right? So for the first stage, I'm going to talk like a little bit, run through implicit. Anybody use implicits here? Probably. Yeah. Some people said like, I don't use implicit in production. So implicit function, actually implicits, like you see here, is, if you know, you probably know that, has several sections. They're all been called implicits, and actually getting a lot of bad rap from implicit functions. Implicit functions are, I think the last, I wrote a blog post about it, but implicit functions, I think the only like place to use that is probably even Java conversions, which I was using heavily, but now it's deprecated in 2.12, or so it's not even in that like really obvious solution. It's people actually remove that. So let's talk about implicit classes. Implicit classes actually is a very, very strong tool. It allows you to enrich object. It allows you to, it's very explicit. It's very IntelliJ friendly, which is important in case of implicits. And it's also one of like really my favorite tools. I use it heavily on a lot of things. Like, for example, if you have 2 case classes, so you write some implicit class, you can put it in a package object, so you get it in the same package like for free, and then you write like 2 functions. For example, this I have this is str and also as another. Those 2 functions actually is very simple. By the way, anybody knows why it's extending anyval? Oh, not a lot. So anyway, when you do this in this, if you write an implicit class and you do it, if it extends anyval, it would actually compile even faster. So it's really efficient when it comes to performance. And now when we wrote this small package object, you can write, if we have some entity, then we can do as str. We actually added this miraculous function, and we can also convert it. And by the way, the options of what you can do with that is limitless. Really, it's really a strong tool. The third one is implicit variables, which is one of the needed for our case. It's some sort of a dependency injection that we can use in Scala. It allows you to get like a smaller footprint in the call stack. It also like once we have a smaller footprint, less ball plate, less function to call to, and also if anybody worked with that, you should probably know that there is an annotation that you can actually customize the compile failure. So for example, if you're using this annotation, implicit not found, you can actually write even a documentation to the user saying like, okay, you're doing something wrong. Don't forget, you can define this. This is the HTML. This is the KB that allows you to define it. So it's easy. It's really customizable. So if we're using, like for example, in my case, I was using an implicit translator. If you put it in the companion object, there is this places where it will look for your implicit implementation. It will be by default. The first one is the call stack. The second one would be the companion object. So now we are putting all of the code that's related to that case class very near it and not near the call site. It's really allowing us to clean up at least the code that we're using. So this is one of the things that I did. It's like you can put implicit translator and then the implementation is there. So we got to the point where we have this implicit translator, but what is the code that we see inside it? The code, like for example, we have this case class, a very simple one. You have a primary key, which is the key. We have two values in it. I just put two of them just to show you how how much boilerplate would be created from this class. So if we wanted to do a new translator, the entity key, which is the primary key, is very simple. We're just taking the member from the case class. But to do the mapping, the actual translation of a case class, it's really very lens if you use that. But it has a lot of code. I think while even writing this example, I was making mistakes because you have strings and you copy paste something, and instead of val1, you write again val1, and it's really error prone. So when you have boilerplate, like I said, it's error prone, and it's also hard to read and maintain. So if someone changes something, and if IntelliJ refactor plugin doesn't catch it, like usually I turn off a few things, because if you replace a string, then it will look through your entire code and then changes stuff that it doesn't want to, and then you have to revert the changes. So when you have a code like this, you really need to be careful. And if someone new enters the project, it can change and break the implementation, and then you'll hit errors in production, and you really don't want that. And again, the main purpose of the project, like one of the highest points that we needed to sustain, was easy integration. And writing like those classes wasn't very easy, at least wasn't for me, and I wouldn't expect someone who wants to integrate with my class, with my library. So to solve that, we have basically two tools. One of them is more of I would say, the Java-like reflection. This is how we can solve those kind of things. But it's also Scala allows us to use different tools, which is the static one. Everything happens in compile time. And the way that we do it usually is with macros. And macros also have like a very bad rap, but for example, if we'll return back to the code that we were implementing using like our implementation of translator, as you see a lot of lines, but they're basically very stupid, but still it takes a while to write them and then to test them. And with macro, we got to the point where this is the code. So you have translator 4, we're putting the entity, and we're putting in string the ID of that entity. So it looks for like the field key, and that's it. This is how you generate a translator. Instead of all of this, And if, by the way, you'll have 5 properties or 10 properties or properties that are nested in each other, the code begins to be very, very complicated. And now we managed to narrow it down to this. But macros, yeah, it's scary, right? Because like everybody is like, macros is probably something like not that bleeding edge these days, but still, it's not something, not such a tool that we'll use for everyday solutions. So for example, like one of the things that I can say about macros is that it really, it's the first line that I wrote about it is it's complex as Scala reflection. It actually has the same API, but Scala reflection is annoying as well, because you have a lot of tools for Java reflections, which makes things a lot easier. But if you manage to learn the Scala reflection way, if you do something with Scala reflection, convert it to macro, it's really simple. But the developer experience is really awful. It's really hard to code. It's really hard to debug. I had a code where I started to put print screens inside it to see the generated code to make it work. And it was really difficult, really. It wasn't something that you can do, like, it's very simple. But on the other way, it gives me a lot of power in a way that I could validate stuff. I will show you a little bit later on. And you can actually provide the failure message if a compile fails. So if something doesn't work, it doesn't compile. And this is something which is very common for type level programming. At some point you can write code that the user doesn't have an option to make a mistake. So for example, if the user writes something wrong, then the code doesn't compile. And if the code doesn't compile, he will fix it until it works, which is something that looks very miraculous. Well, it's nice. I write a code that nobody can fail with. But on the other hand, I can say that if you abuse that too much, like if you write something too complicated, and a developer would spend like, I don't know, 4 hours watching a code that doesn't compile, it's really frustrating. I think the most frustrating thing that I had in any project that I got throughout my career is going to a project and it doesn't compile. It's like one of the Nathan from, if anybody attended the lecture, talked about Bazel, which are a build tool. But I remember days before Maven, and I would get to a company, and I think the first month, the code wasn't compiling, and I was like really frustrated with that. And the minute that Maven was like, I could download a git clone, get the project, do a Maven clean install, and everything compiles and everything is read, it still looks like magic to me. So really, code that doesn't compile for a developer is something that like you really get upset with it. And if you have to spend a lot of days working with code that doesn't compile, then well, your integration will, like people say, like, I can't compile it. It's just like it's not going to work. So, but still, if it doesn't compile, macros allows us to give even an error, our meaningful error, and then that tool by itself, like allowing to control the compiler output, is very important, even with implicit, as I mentioned earlier. So this is one of the things, like if you see this code, what can we validate? So for example, you see that we're putting a string value called key. So some entity should contain a property named key, and the macro code for it looks a little bit awful, but still, it does something very simple. It finds the field name inside. This all will happen in compile time. It will try to find it, and if it finds it, then it will create the code that gets so for example here, entity key field dot named to term, and you see the quasi codes and everything. This will generate the code that will do some entity dot key. But if it doesn't find the field, then this line would say entity key doesn't contain the field and will give the name of the field. So if someone writes instead of for the translator for some entity, if he writes key 1, then not only that the code won't compile, and it will tell him that I can't find the field key. I'm not very good at writing error descriptions, but I'm sure like once people can write more meaningful error message. But still, this is a lot of power in our hand. And once we found that, we actually could get even more value from that. For example, one of the requested features is that someone wanted us saying, someone was saying, I don't know that some entity is going to be translated. I want to be able to tag it with some annotation in order for people to be aware that if they're changing something, that they should be aware of that. And one of the other things that I realized is that I can put even more customized options into the annotation. So it was very good for me. But what do we do now? So now we have an entity and we can add some code to the macro. So the code that you see here is actually reading the annotation from the code in compile time, generates code according to the annotation, and actually, like, for example, the last line, the get or else here, it actually saying, hey, well, you have to have an annotation on that object. If you don't have an annotation for that object, no, you can't have it. Will not compile, and this is the error message. So this sort of ability even allows us to generate even more code using macros, which was really nice for us. And small cap on what we did, like while the refactoring, we did all of those stages and we got to a result which is basically one parameter, which would be the minimum amount of parameters for us. But still, I'm not going to release all of you to say like, okay, I'm going to add macro tomorrow to my project. Because, for example, one of the final tips that I want to give you with this lecture is that remember this principle. Remember that we cannot abuse our code to contain like really cool features that nobody else would be able to maintain later on. It's like code, you write the code once, and if you write the code that nobody else can maintain, well, you can't move on. You're going to stay with that project forever. You'll have people opening a Slack conversation saying, oh man, I know that you wrote this and we have this bug, come and sit with us, because we don't know how to work with macros, or we don't know how to work with shapeless or all of those other advanced tools. And I'll give you a small example that I also encountered in the project. I had to convert a case class into a dotted notation object. A dotted notation object means that the value is encoded into like a dotted string. So for example, you have an object with A, with B, and inside it there is another one with B and another one with C, and C's value is val1. So to write a thing like that with Scala, anybody like want to think about it? So it took me, I use shapeless to do that. I actually even have the pull request still open somewhere. If anybody want to see it, you can come to me after the lecture and I'll show it to you. It took me about 3 days to code, 100 lines of code, and it was extremely hard to maintain because I don't think anybody else got the shapeless thing other than me in the company. And to put something like this in the code is, like I said, it's gonna tie me forever to the project, and I'm moving to other places. And sometimes, even if you let one of my employees to do that, and he decides to move to another company, then I'm stuck with this code. Code you write only once, but you maintain, well, at least for like 2 years until the service is dead. But unluckily for me, I see that all the bad projects seems to last forever. I don't know why. It's like everything that was really architectured right, that's like, oh, the user doesn't like it, and it's like, it's really bad. And the projects that everybody did like in 2 minutes, and it's like, oh, we're just gonna put something, nobody would use it. They're kind of living forever. Anybody want to guess how much lines will it take to do it with JavaScript? Yeah, let's count. This is the code that does it. It took me like 2 minutes to find it in Stack Overflow. This is actually one of my implementation. I did it more functional, as much as I could with the JavaScript. But this code is basically very simple. It's like anybody who knows JavaScript and learned to code like more than, I don't know, maybe like 3 days can write. other than like shapeless, which is I'm really it's like you can use shapeless. I wouldn't say I won't give any bad reps, but I would really consider before putting it in a project. But again, a JavaScript, it's, let's say, it checks something, object.assign, because types are actually built into the code in JavaScript. It's not some extension that something. Everything is dynamic. Not that I'm saying that you should use JavaScript. Not that I'm saying it's a programming language, but still. But still, when you compare the tools, like to do something like that and to do something with Scala, it's there is no like competition. And at the end, I closed the pull request and I actually moved this code into the node component of my service, just in order not to leave that code over there. And I have other code that writes in production well, it's not in production, it's in test code that uses shapeless. If anybody's using shapeless, you can see it. You probably, because it was contributed there. It's called case class diffs, one of my pull requests there. And it will allow you to actually compare two case classes and tell you which property is different. But again, so in that scenario, it was needed. But for example, when the option is 5 lines of JavaScript versus 100 unmaintainable Scala code, I would go with the JavaScript. And with this, I will conclude. I hope you enjoyed the lecture, and I hope you are more open to use macros or more advanced function, but remember, with caution, with consideration to other people who will maintain the project, but there's nothing to be afraid of if it's needed. And if anybody have questions, I'd be more than happy to answer them. Thank you. Okay. So, oh, sure. Yeah, there is one.
So in the last slide you showed with JavaScript. So as I understand, maybe it's not really fair to compare. So in JavaScript you use it in runtime, and with shapeless it's compile time, right?
Yeah, in this.
But I mean, if you do like the same in Scala with in runtime, it will be like the same number of code. For example, a Java object mapper will do it easily as well, which I think it should.
Not exactly, because
I mean, doesn't it sound correct that we compare compile and runtime?
Of course we can't. I'm not, like I said, I'm not saying okay, JavaScript is good, Scala is bad, and I'm not saying actually I tell the Scala is good and JavaScript is bad, but let's leave that aside. But still, when you're considering new technologies, the JavaScript is new or Scala is new, but still, when you're considering a tool to use to open to solve a solution, you have to find the right tool for the job. And in some cases, JavaScript is great. In some cases, Scala is great. You just have to be aware of what you're working with. Okay, so don't get in love with Scala and saying like, okay, Scala can solve everything in the world, because Scala has a set of specific problems it solves really well, and a set of completely different problems it solves really in a shitty way. So
I think in this case it's just the way objects are done in JavaScript.
Yeah,
this thing is just natural there, because you just have to use that, and in Scala it's or all JVM languages that are really that it's very far away because it's hard coded and not there as strings. And so I think it's legitimate that you have a toolbox and you have certain things in the toolbox, and you just don't use the hammer to plug in all the screws, but think of screwdrivers and whatever else you have.
Some people think that you just need to use a stronger hammer, but like I totally agree with you. This is one of the things that I said. The types are actually, the node types are actually built into JavaScript. So when you write it in Node, it's I basically, even writing this was redundant because there was a library that does that in NPM, so I didn't even have to write those lines of code. But still, this set of problem, this specific problem was very solvable with JavaScript, and a lot easier to solve with JavaScript. So when I decided where to put this code, even I had those two options, I decided to go with the simpler that anybody can maintain. Any more questions? Okay, so I'll be walking around here if you have like anything you want to ask me. Thank you very much for your time.